Okay, guys, so we're still navigating our way through this whole vertex form thing with our parabolas. Okay, so if you take a look at these problems here, you're probably going to notice the difference here now is that I have a number in front of the parentheses. So we're going to work today with numbers in the A position. Okay, we're going to stay with nice, neat whole numbers today. We're not going to navigate into fractions yet. Okay, but that's obviously going to change the way that our graph looks. All right, so to do a little investigating here and just to kind of show you what happens here. Okay, if we go to, all right, Desmos, okay, this red parabola that you see is the graph of this top equation up here, which is the type of equation that we've already learned how to graph, right? You would have a vertex of the opposite of 4, which would be, or the opposite of -4, which would be +4, comma -5. So that's that point you see right there. There's your vertex. Okay, and then we talked about the parent function and figuring out how to go right and left. It would be 1 right, 1 up, okay, 2 right, 4 up, and so on. Okay, so there's your parabola. We'll get back into parent functions in a second. Now, if you notice in the second equation, I threw a 6 in the front. Okay, let's see what happens to the graph when you throw a 6 in the front. All right, if you notice now the graph popped up, it's the same parabola, just obviously it's a lot skinnier. Okay, so the graph just became skinnier. The vertex didn't change. Okay, it's still obviously opening up. None of that changed. All right, it's just a little bit skinnier. Okay, if I take that away and I go to this last one, there it's 1/6. It's a fraction. You can probably figure out that if a big number makes it skinny, a small number like this, like fraction, is going to make it big, right? It's going to make the graph a little wider, right? A little fatter. It's going to take that U and push it out. Okay, it just means it's extending upward a little bit slower, okay, which is why the graph is wider. Okay, and then obviously if I wanted to do one more thing, guys, and you'll see when we start graphing these, if I wanted to take that number in front and I wanted to make it into a negative, okay, you see the graph disappeared. It didn't really disappear. Now it's opening down. I could do the same thing with that -1/6, same exact graph opening down. Same here, I could put a negative. I got the same exact parabolas, guys. They're just going in reverse. They're going down. Okay, so that A obviously affects the graph. The bigger that it gets, the skinnier it gets. The smaller that number gets in front, the smaller that A, the wider your graph is going to be, the bigger it's going to be. If it's a positive, all right, I go back to my original numbers there. If it's a positive, it's going to open up. If it's a negative, it's going to open down. Okay, so that's how the A is going to affect our graph. So if I go back to the problems here, okay, we can make a couple predictions about our graphs. Okay, like if I look at this problem right here to the left, okay, we'll call this number 1. Okay, your vertex is going to be the opposite of H, right, which is a -1. So my vertex is going to be at 1 comma K, 1 comma 3. So my vertex is 1 to the right, 3 up, which is right there. Okay, let's get that out of there. All right, now let's look at our A. Your A is positive. Since it's positive, I know my U is going to go up somehow, some way. Not necessarily like that, but it's definitely going to go up. And because I don't want to say it's a big number because 2 is not a big number, but 2 is not a fraction. Okay, it's a whole number. Whole numbers are going to make the graph skinnier and skinnier and skinnier. So this is going to be kind of a skinny little U here. Okay, now we talk about our parent function. The parent function involves everything but your H and your K. So the parent function here is going to be y is equal to 2x squared. Okay, so my parent function for that first one is y is equal to 2x squared. So when I go to make my xy table, okay, and I'm going to use same numbers I used the other day, 1, 2, and 3. Okay, I plug them in. So for 1, it would be 2 times 1 squared, which would be 2 times 1, which would be 2. So that tells me from that vertex, I'm going to go 1 right and 2 up. Okay, so my next point in my parabola is going to be right there. For 2, it's going to be 2 times 2 squared, which is 2 times 2 squared, which is 4, which is 8. So from the vertex, I'm going to go to the right 2, 1, 2, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I went 2 to the right and 8 up. Okay, then for 3, I don't know if I'm going to be able to fit 3. I doubt it, but I might as well do it just to see. 3 times 3 squared, which would be 3 times 9, which would be 27. So that tells me I'm going to go 3 right, 27 up. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I ran out of space, but you get the idea. Okay, so that's the path that my parabola is going to follow. It's going to look something like that. It's eventually going to go up there and hit that next mark. Okay, and we talked yesterday too about the line of symmetry, right? You got your line of symmetry cutting right through the vertex. Okay, so that's how I find my mirror points. So this point is 1 to the right. I can flop over 1 to the left. This point is 2 to the right. I can flip it over here. And then that third point I can't find, but we get the idea. It's going to be somewhere, in this general area up there. So the second half of my U looks something along the lines of that. Okay, obviously it's not going to be perfect. You're drawing these by hand. Okay, hopefully that makes sense. That number in front, okay, made it a little bit skinnier, and it changed the values, guys. It changed my values over here. Yesterday they were a little bit easier, a little bit smaller, just a little bit bigger today. Okay, if I take a look at this second problem over here, okay, the vertex is going to be the opposite of H. So the vertex is going to be at 2, comma, K, which is 6. Okay, so it's going to be 2 right, 6 up. 1, 2, 1, 2, 3, 4, 5, and 6. There's a reason I set up the coordinate grid the way that I did. If you look at your A value, guys, your A value is -3. The main part there being it's negative. So this graph is going to go down. Okay, not only is it going to go down, but your A is also a nice, neat whole number. So it's also going to be kind of skinny. All right, this one's not going to be a wide one. So this is going to be a skinny graph going down. All right, my parent function here, okay, is y is equal to -3 x squared. So your parent function is y is equal to -3 x squared. Okay, we make our xy chart here. Okay, 1, 2, and 3. Okay, so for 1, it would be -3 times 1 squared, which would be -3 times 1, which would be -3. For 2, -3 times 2 squared, which is -3 times 4, which is -12. And then for 3, it's -3 times 3 squared, which is -3 times 9, which is -27. Okay, so these are the values I'm working with off of that vertex. Okay, so from my vertex, all right, I'm going to go, so for here, all right, there's my vertex. I'm going to go 1 to the right and 3 down. So 1 to the right, 1, 2, 3. There's my next point. And then I'm going to go 2 to the right, 12 down. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Then I went 3 right. This is at 12. So 13, 14, 15, 16, 17, 18, 19, 20, 21. I'm going to run out of room, but you see the idea. So the one half of the graph is going to look something along the lines of that. Okay, you got your line of symmetry there. Okay, cutting right through the middle, right through that vertex. Tells you you're allowed to flip the graph over. Okay, so this point flips over here. This point flips over here. And then that third point would obviously flip somewhere in the ballpark of there. Okay, so the second half of your graph is going to look something like that. I'm a little bit off there, but you get the idea, guys. Your U is not going to be perfect. Okay, you're not going to be able to fit, a ton of values here. All right, but now you have an idea of what these graphs are going to look like when there's a number in the A position. Again, the problems that you're going to see today, I haven't dove into fractions yet. We'll get there another time. Okay, they're going to be nice and neat. So all your graphs are going to be relatively skinny, depending on how big the number is that I give you. And remember, if that A is positive, that means it's going up. When that A is negative, that means it's going down. So you can actually predict before you even do the problem you can give yourself an idea of what this graph is going to look like.